Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to write unsafe C# code. This lets us disable the safety features of C# so we can access raw memory and do anything we want with it. Okay, so let's see how to write unsafe code. Now this is a very advanced topic. When working with raw pointers, it is extremely easy to mess up. You can corrupt some memory and crash your program, or you can simply end up opening your program to all kinds of security vulnerabilities. So this lecture is very much just a quick introduction to the topic, just so you know that it exists. I myself am not an expert in unsafe code. I've never really used it myself in any serious project, I just know that it exists. In order to properly use unsafe code, you need to know exactly what you're doing. If you don't, you're going to cause a lot of trouble, so always keep that in mind. Now, before we cover unsafe, how exactly is C# safe? Well, C# actually has a ton of safety features, mainly to do with memory. For example, when working with a language like C, when you want to create a brand new variable, you need to manually allocate some memory for that variable. Whereas in C#, that is all handled automatically. So if you define an int I equals something, this automatically defines the memory for this integer and automatically assigns a value. Then when reading some memory, like for example a string of text, you need to know how far long to read. You need to read it character by character. Whereas again, in C#, you just got a string with something, and then you can easily read it and say something to it. When working with pointers, you can have pointers to invalid locations in memory, whereas in C# you simply have null. So that and tons more things. Basically, C# tries to protect you as much as possible. And of course, the downside of all of these safety features is naturally it makes the code a little bit slower to do all of these safety checks. That is why, in super performance-intensive applications, usually you write it with C or C++. For example, while you write game code in Unity and C#, while you do that, the engine itself, that one is mostly written in C++. The entire engine has an entire pipeline to basically have your C# code communicate with the backend C++, and the reason why it's in C++ is exactly to have access to all that raw power without that safety overhead. But again, the engineers that work on the Unity backend, they are experts, which is why they can work with pointers without causing all kinds of issues. Now, in C#, in order to write some unsafe code, it's actually pretty simple. You just use the unsafe keyword. Now you can mark an entire class as being unsafe, you can mark an entire function as unsafe, or you can simply define a code block, and just as code block is marked as unsafe. Now inside of this we can write any unsafe code, like accessing pointers and allocating some memory. Although right away you can actually see an error. It is saying unsafe code may only appear if compiling with the unsafe. So we need to first set up the project to actually support writing unsafe code. By default it does not support it. So for that, let's go onto the Solution Explorer, let's right click on the project itself, go into Properties, and over here let's scroll down, and over here under Build, we can see, yep, here's a checkbox to allow code that uses the unsafe keyword to compile. So yep, let's enable this, and yep, the error is gone. Okay, great. So now in here we can use pointers. For example, we can define an int pointer, and the way we define a pointer is first to type int, and then a little asterisk. So this is an int pointer. Let's call it like int array pointer. And in order to allocate some memory, we can use stack alloc. Then let's allocate memory for an int array with, let's say, 10 elements. And if this is going to manually allocate some memory for an int array, then for example, if we want to read the memory location for this, we can grab the int array pointer, we can cast it down to this type, the int pointer, and let's just print this to see what this says. So let's do a console.writeLine. Let's print out this. Let's just do a toString to convert this into hexadecimal. So toString with format of X. Okay, let's see. And if there it is, we allocated our pointer, our int array, and it ended up being allocated on this exact memory address. Now let's read the entire memory address location. So let's do a simple for int I equals 0, I less than 10, I plus plus. And for this int array pointer, we can access this as if it was a normal array, so just access that one. Let's do a console.writeLine on this one. Okay, let's see. And yep, it's all in zeros, makes sense. But now let's see another thing. So we are allocating with 10, and over here, let's actually read 20 positions. And if you look at that, this did work. Usually, if you try doing this in non-unsafe code, in normal code, if you try to access this array on something bigger than the index, if so, then basically normal C# code would have a bunch of safety, and that safety would stop us from looking beyond the index bounds. If we tried, we would get an index out of range exception. But over here, when working with unsafe code, we don't get that. We can read the memory beyond the array, and doing so, we're basically going to get gibberish. So the first 10 positions, those have been initialized as new int array, so those are guaranteed to be initialized to 0. But these other ones can have really any memory. This memory does not belong to the int array, it belongs to something else. But as you can see over here, the unsafe code does not stop us from accessing it. So even though the int array only has a size of 10, we can go all the way up to 20 and even more. By the way, this is actually the basics for how hacking programs work. things like aimbots and wall hacks. Usually they read memory they're not supposed to, and then interpret it in some way, like for example display an enemy behind the wall. And the pointer itself, this one is also, like we saw here, it's just a position in memory. So we can take this one and, for example, let's increase it. Let's increase by some amount. This basically means we're going to look at a memory location for it, which again is going to let us read a bunch of garbage. So up here, let's read just 10 elements, which without adding this one, we would see everything with zeros. But now, yep, we see a bunch of garbage values. So pointers are really just numbers to a location in memory, and you can increase that number. You can do whatever you want to read a different location in memory. Now the asterisk over here, this one defines a pointer, and then another symbol, the ampersand, that one defines the memory address. So for example, let's make over here a simple struct. Importantly is that pointers need to work with unmanaged memory. Again, the entire concept of managed memory, that's a C# thing. C# automatically manages memory for you. But when working with pointers, when working with unsafe code, we are intentionally not using any of that. So when working with unsafe code, we're pretty much limited to just using unmanaged data. So that is why over here, let's find a struct for some kind of game data. Then inside, let's define some kind of value for some coins, and then maybe a bull is game over, something like this. So now up here, let's say we construct a brand new one, game data equals just a new game data. And now let's define a game data pointer. So this is not of type game data, it's a game data pointer, so game data pointer. And for this one, let's make this pointer point to this structure right here. So for that, we use the ampersand in order to get the actual address in memory of this game data. And yep, so now we have this pointer, and this pointer is going to point to this data. And now, for example, for accessing data inside a struct, for that, we access our pointer. And now, normally, when working with C#, you would do .coins, something like this. But over here, we are working with pointers. And when working with pointers, or when writing some C code, to access a sub-element of this object, for that, we do a little arrow. And then we access, for example, the coins, and we can set it to something. And then same thing for the other one is game over, we can set it to something. So yep, this is how we can access some members of some data, some type. We grab the pointer using the location memory, and then access those members and do whatever we want to. Then you can also declare pointers as function arguments. So for example, let's make here a function to raise something to the power of 2. So let's make a static function, just because over here we're in the static thing. Let's make it void and call it power 2. And over here, let's receive a pointer as a function argument. So instead of an int, let's receive an int pointer. Yep, just like this. Except, of course, we see an error. We can't use pointers. We can only use them in unsafe contexts. So let's mark this entire function as unsafe. And yep, that does work. And now we want to modify this value. So to modify the value, we access the pointer itself. And then we're going to set it to something. So in this case, power of 2, we want to basically put this value to the power of value. So let's do times equals, just to do the multiplication. And then times equals, again, the value stored inside a value. So not value like this. This is an error. We don't want to get just the pointer itself. Instead, we want to get the data where that pointer points to. So let's put a little asterisk to get that one, just like that. So that inside of here is going to multiply itself by that one, and that will basically do a power of 2. So then up here, let's use it. Let's find some kind of value. So int a equals 5. So just a simple integer. Now call the function, so power 2. But now we need to pass in a pointer, not that itself. If over here we use just a, yep, we have an error. It's telling us cannot convert an int, meaning just a simple integer, just simple value, to int star, meaning an int pointer. So we need to pass in the pointer, which means we need to pass in the memory location, just like this. And if that's it, that works. Now, one interesting thing, since we are working with pointers, meaning that this is going to point to the original position in memory, even though over here we are working with an int, which is a value type, and normally if we made this kind of function, and over here we receive just a normal int, with that, if we then multiplied it, we would only be modifying the copy itself and not the original data. But since over here we are passing the pointer itself, if we do a console.writeLine on this one, on A, if there it is, it says 25, so 5 to the power of 5. So the function, this one modified the data on the variable itself, even though it's an int, and the reason is because we're dealing directly with pointers. Then some objects might move around in memory. If you have some kind of managed data, like for example, just a simple managed array, if you have something like this object might go into different positions in memory. So if you want to do something, you can use the fixed keyword, and this one is basically going to generate a pointer. So a byte pointer equals our bytes. And yep, basically this one over here, the fixed, this one is going to generate a fixed pointer to this object. So whilst inside of this fixed code block, we can make sure this byte pointer is valid, but when outside of it, this object might move to a different position in memory. Okay, so that's how you write unsafe code and deal with pointers. Like I said, this is a very, very advanced topic. It is very error prone, so definitely make sure you know what you're doing. Unless you're writing some code in some embedded systems or something super hardcore like that, chances are you really don't need this. C# has a ton of really awesome safety features that are meant to protect yourself. Those are really good, they help you write much more error-free code much more easily. So only disable those when absolutely necessary.